Hello everyone, myself Yamini Agrawal from the Department of MCA on behalf of Vesit welcomes you all for today's session of the event We Reach 2020, an Alumni Engagement Initiative. Now I would request Professor Dashrath to come and put some light on the today's session. Now over to you, sir.
Good evening all and welcome to today's session under VReach. VReach 2020 is an alumni engagement initiative by Visit under the guidance of Internal Quality Assurance Cell and in association with the Institution's Innovation Council. Today we have with us Mr. Prabhanath Nair, who is a software engineer with General Mills. Mr. Prabhanath is our 2017 MCA pass-out student. And today he'll be talking more on containers and Dockers. I would like to welcome Mr. Prabhanath and requesting Prabhanath to kindly proceed with today's session. Thank you so much.
A very good evening to one and all. Today we'll be talking about containers and Dockers. We have a tight agenda today. I'll be just walking you through the brief of each of these points. We'll just talk about the application trends and what's changing or evolving the current application space that we have. I'll just walk you through briefly about what is the continuous integration and delivery that we call as the CI/CD pipeline, on how our application moves from your machine to the actual server and how it actually gets deployed to a production server. Then I'll just walk you through about the basics of Docker, the history of applications and how it has been evolving since a decade. Introduction of containers and how containers and Dockers work hand in hand, and Dockers in depth and what's next for us. So moving forward, movement in cloud. So cloud is a booming word that we see on a day-to-day basis. So why cloud, right? So there are a few reasons on why the companies and the corporates are moving to cloud. So as per the recent survey that's conducted, around 80% of the companies think that movement to cloud is useful for the company. So what is the reason for that? So it eliminates redundant tasks like the data entry and stuff that we have to do on a day-to-day basis. It reduces cost because we don't have an actual server on or a server data warehouse on premise, which further reduces the cost and the flexibility in terms of accessibility, wherein people can access it from anywhere. So we can reduce the number of workstations that we have on our premise and just allow people to work from home. Scalability. So scalability is not a big issue in terms of cloud, wherein we don't have to buy physical servers and each server might cost you billions of dollars in terms of the size it requires. And there is no downtime in cloud. So they assure 24/7 uptime and the security is never compromised. So these are the few features on why companies are keen to move to cloud. So those were the few points. Applications are transforming, which is fairly true, right? So applications are transforming since 2000. So if you see from the early 2000s, we used to follow monolithic architecture. So basically what monolithic architecture means, you have a single code base and wherein you have multiple modules which are working based on their requirements. So that is one kind of coding that we have, which is called monolithic architecture. And then you had a big servers wherein you had the giant data warehouses, for example, the Google and the Oracle guys had. So those are the real physical servers that we had. So now we are transforming from those. So now we no more have the real big servers. We do have a bit, but it's fairly less than what we had in the early 2000s. So it's moving to the microservice architecture. What do you mean by microservice architecture? Something that we'll be seeing in the coming slides further. So that is what we call as application modernization in terms of a developer and in terms of how we write the code. So that's what is changing and evolving, right? The application code that you see, just the figure that you see on the left. So it basically talks about the monolithic architecture wherein we have everything at a single place. And the modules are within a single base code. So that's what is changing. So we have a different modules which are loosely coupled and each module is only supposed to do a specific operation and not more than that. So that's when it becomes loosely coupled and very lightweight, and it can be easily scalable, and which also makes it independently deployable also. So this is a service based architecture. For example, if you want to have a API written, so those are service based architectures wherein you have an API to do a CRUD operation, you have an API to do an authentication. So those are different kind of services that we have, and those can be independent of each other, and it can be used together in an application. So it ideally doesn't need to be tightly coupled between each other. So that's the difference between a monolithic and a microservice architecture. So we'll be using these words on microservice architecture more going forward, because that's the way forward to go. So now this is something that I mentioned earlier about the continuous integration and delivery pipeline, which we in short call as CI/CD pipeline. So this is a basic architecture on how your code moves from your development machine, and there is a testing environment in between, and then it goes to production. So what's changing? From a developer standpoint, there is nothing changing in terms of the way you code or how you code. A bit changing is in terms of the architecture and how your application looks like, right? So earlier you used to have a monolithic application wherein it was tightly bound under a single code base. Now we'll be just dividing it and making it into bits and pieces, which we call as a microservice architecture, wherein it will be loosely coupled, and then it will go through a CI/CD pipeline. So what is CI/CD pipeline is when something that you see here, so which is called as Jenkins. So which takes care of pushing your code from your local machine to the server. So this is on cloud, and why it is again on cloud? For the obvious reasons that we talked earlier. On the left, so organizations must deal with the diverse technologies, right? So on the left, you see a traditional architecture on what we have, wherein we have a bare metal and you have on-premise servers, you have Linux servers, and there's a traditional code base that you write. It has changed on to the virtual servers, wherein you don't have a bare metal servers on premise. It's already on cloud, and you're changing your way of coding to microservices. So this is the change that we are talking about. So there is a common myth in IT wherein you say the old infrastructures cannot be migrated to microservices, and only the new code or the new code bases can go to cloud. So which is totally incorrect from what I believe. So both the old infrastructure and the new code base can go to cloud, and it can be converted to microservices. So microservices gives you an different perspective of coding. It gives you a tight hold on each of the operations. So that's one way of looking on microservices. And there are different agile traditional applications which are already decoupled, and also the traditional applications can also move to cloud, definitely, but it will be a tough time to move those traditional applications because it is very tightly coupled in terms of the database connections, in terms of the security, and in terms of the authentication. So that's when microservices acts as a bit different, wherein it's easy to check wherein the code is failing and where the issue is. So that's how microservices play an important role in terms of moving into any infrastructure, may it be cloud, may it be on-premise. Next, we'll be talking about Docker and containers, just a basic overview from how Docker has evolved. So it all started in 2014, wherein there were a few technology companies who just introduced Docker, and they just started earlier it only for Linux containers, wherein it was only working for the Linux machines. So it was again a test POC back then, and then it evolved slowly in 2013 when they opened it to the open source community. So now Docker currently is fully open sourced, and they also have enterprise edition of it. We can talk about it later on, but we'll be mostly covering about the Docker community version here. So the incredible adoption of Docker in just 4 years, right? So you have different people contributing to Docker project. There are images being pulled. There are pre-loaded images that are created for use cases already by someone. So that's how the evolution of Docker is so significant in the years that it has been very useful. So let's continue talking about the Docker family tree. So as I said earlier, the Docker started from a Moby project, which was an open source project. It was just started as a POC, which then developed into an open source community and many contributors contributing to it. So as I mentioned, there are different versions of Docker. One is the community edition, which is free, available for the developers, and delivering the container solution. It is basically for the developers to test and play around with the different commands. That's when Docker community edition helps you. So it's basically for you guys, wherein Docker community edition can be a great start on playing around with Dockers and learning what Docker containers are and what is Kubernetes and what is orchestration and those all stuffs. So Docker Enterprise. So Docker Enterprise basically gives you dedicated support in terms of the corporates, wherein it's used in a secured way, wherein it's integrated with the continuous integration and continuous development pipeline with the corporates. So that's where the Docker Enterprise comes into picture. So let's talk about maybe the history of applications and how it used to look into. So this is one of the from the dark ages, as it's mentioned, right? So this is one of the oldest architecture on how applications used to look like. So there used to be a physical server and there was an operating system and over it which the application usually runs. So this is kind of an monolithic architecture that we can say, wherein we had a physical server and there used to be an operating system over it, and based on the operating system, it can be Linux or Windows, the applications used to run. So this was one of the kind of architectures. And there were a few limitations, right? So that's when we try to move around with innovations. When we have limitation within existing, then we evolve and come up with new ideas. So there were a few limitations again with the historical application deployment. It was slow since it was running on a single operating system, a single physical server. It used to take time, and there was a huge cost associated with each of the physical servers in terms of scalability. If we wanted to scale a physical server, we need to purchase an actual physical server onto our data warehouses, and each server will have a different operating system and a specific application will be associated to it. So that's how the cost is increasing on that front. And there are a few resources which are wasted. For example, if we require 10 gigs of memory and you have 5 gigs of memory per server, and I just purchase 2 servers, for example. So that's kind of distributed in terms of the memory. But if we have we only require 15 gigs of data, and we have around 15 GB server, because each servers are meant to be having a specific memory allocated to it, and we cannot decrease it based on our needs. We just must purchase those particular servers, and that's how we might waste some of the physical servers that still just keeps lying out there, and it's difficult to scale, as I said. So in terms of scalability for each application, as it's tightly coupled to an operating system and a physical server, is pretty much difficult in terms of scaling it into a few thousands of applications. So, and it's difficult to migrate, right? So if there is a data loss, so there needs to be a software or hardware engineer going physically to that server locations or the data warehouses to check out the issues and fix those out. So that's how it's difficult to migrate, and it's difficult to troubleshoot in terms of any issues that occurs. So to come up with those issues, or to get over these issues, we came up with something called as virtualization. So there is hyperversion based virtualization, wherein we have a different layer of hypervisor which comes in between the operating system and the actual applications. The physical server still exists, but we have a different hyperversion which comes in between. So that's one of the virtualization evolution that happened after the application phase that we had in the earlier history that we discussed about. So wherein here we have a one physical server which can contain multiple applications. Each application runs on a virtual machine. So that's when the hypervisor comes in between. wherein we have different operating systems acting for each application, and there are different VMs working on it. So that's what we call as virtual machines. We have different VDIs, we have different Oracle machines that comes, I guess you might have used in your college practicals, that we call VLabs. So those are different virtual labs running on your same operating system with a distributed memory architecture. So that's what we call as virtualization. So what are the benefits of virtualization? It basically comes out with the different limitations that we had earlier. So virtualization takes care of better resource pooling, wherein one machine is divided into multiple virtual machines, and the space or memory or the resources are divided equally for each of the virtual machines. It's easier to scale, right? So if I need to have 10 virtual machines on a physical server or a physical application or a physical operating system, it's quite possible, right? It's easier to scale in terms of how many virtual machines that we require on a single physical server, and VMs in the cloud. So VMs have been evolving. It has been evolving in terms of the recent past until the cloud has been coming up in the recent. So VM has been a boom in terms of overcoming the history of applications and how it was tightly coupled to a physical server. Again, the physical server still exists, so which means there can be some limitations again for the virtual machines. So there you go. So there were again few limitations for the virtual machines, which required the CPU allocation, the storage, and the RAM, which was still physical. It used to require those for each of the VMs that we used, though it used to share it, but the amount of physical cost or the physical devices or the physical storage that is involved in each is still the same. So it gives you more usage in terms of the scalability, but it is still using the same physical devices or the physical storages. The more VMs you run, the more resources you need, which means the more physical storage or the physical resources you require. So those were the limitations of virtual machines. The guest OS means the wasted resources, right? Again, so guest OS is not required. It was just created in terms of a backup, so which again uses the resources. It also uses the physical storage, but it can be a mode of just wasting or keeping the resources just as it is. So that's when containers come in, right? So what is containers? So containers, as the layman word defines, it's something which can contain a set of storage devices or a set of memory allocation kernels or a set of applications. So anyways you define it, so that's what a container is. So if we go by definition, it's a standardized packing for software and its dependencies. So when we talk about software, there are a few dependencies associated to it. So for each software, there is a database required, there is an authorization base required, so there is an authentication module required. So each of these are the different dependencies for the softwares, and there further it basically isolates the application from each other, which means a container can run many applications working isolated from each other. One application can have just a single page application, which we call as an SPA, and another can have a database structure, and another can be just an API application, so those kind of things. And another can be a job, which can be a title job, a console job, or any kind of thing. So what is of advantage of containers? So basically it shares the same OS kernel. So when we say the same OS kernel, the resources are equally divided. The resources are equally divided amongst each of the containers with help of the Docker images. So there is one more layer that comes in between the kernel and the containers, which is called Docker. So what Docker does is, so each of these application has a set of requirements that it requires. For example, if we take from the left, it requires a Tomcat server. It is working on Java, and there is a Debian that's required. And if we take the middlemost container, it requires SQL, it requires .NET, and the platform is Ubuntu. So that's when the Docker file comes in, wherein we specify what all our requirements and what is something that we require for each of these applications. So this is just a comparison of containers and virtual machines, since we talked about the virtual machines a while ago. So it would be a bit of interesting in terms of comparing these two. So this is basically how a normal container structure looks like, and this is how a virtual machine looks like. So there is an hypervisor which we have removed because the containers is directly working on the host operating system. There is no hypervisor in between. So what I mentioned in between is a Docker. So Docker again is a set of images, which means a set of files. Again, in layman terms, it means a set of config files. So these are the key benefits of Docker containers as compared to the earlier application where we had a single server, and as compared to the virtualization architecture which we had post that. So these are different benefits in terms of speed, in terms of portability, in terms of efficiency. So that's what keeps out containers, and that's what keeps different containers and Dockers from all these evolutions that has been happening in the application space. So container solution and the landscape. So we'll talk about Docker a bit here. In terms of the Docker file and what all are the components in the Docker config file. So what is a Docker? It's again just an image of what your application requires and the content at the rest. So you will still have that application. You'll have a Docker file which is purely an XML file that you can talk about. It will be a YAML file, which is a different mode of configuration file, but at the end of the day, it's still a configuration file, which talks about what all are the resources that's required and what is the kind of resources required for your applications. And then it runs on container. So when the Docker image is running on a container, so it's standard unit of the application service, right? And again, it runs on an engine which has a registry of its own, and there is a control panel wherein we can manage the orchestration of the clusters and the containers. So this is just an high-level architecture on what is the integrated security which Docker engine provides. So it again also has a security with it. So you can also provide the security which is required for each and every Docker images. It can be again public and private. So it depends on your requirement and what are the volumes or what is the container runtime that's required for each of the Docker images that you create. So this is just a high level overview of building a supply chain software system. So when we just look from the left to right, it's basically from the developers to the IT operation guys who actually use those applications. So for the developers, again, as I mentioned, it's basically the microservice architecture that we need to follow in terms of running it at the end user's perspective, and in terms of the high speed that the application can give, and also in terms of the deployment process that it helps in. So the microservices are, as discussed earlier, very loosely coupled and very light, which makes it very easy and very quick in terms of the deployment process and the image registry, wherein it stores all the images that is created for each of those applications. So the image can be again a config file wherein we can have different images for, say, .NET application, for .NET Core application, you can have for PHP application, you can have for Python. There can be multiple images, and it just needs to be pulled into the control panel, which runs on a container engine, and that's how your application runs at the end of the day. So now, since we know a bit about what is containers and what is Dockers, so we'll talk about containers as a service, right? So how we can leverage container in terms of our CI/CD pipeline. So what you see is build, ship, and run. So these are few steps or few processes that is required in terms of taking containers and Dockers at the end users hands. So basically, build is something that a developer basically does it in terms of building your softwares and getting it and out into the registry. So the registry, again, as I mentioned, stores the images, and the images is something that we push in, saying if it's specific to our use case, we just use an existing image and play around with it and put some code that is custom to our use case. So that's how the ship works, and then deploy, manage, and scale it, wherein it goes to a CI/CD pipeline. It can be Jenkins, it can be GitLab, it can be any kind of CI/CD pipeline which basically automates, or what it does at the end of the day is copies your registry runs it onto container engine, which basically says I want to pull this particular image from this source. So it will pull that image, it will store it in that management control panel for Docker, and that's how it runs at the end. So now, since we have discussed about container as a service and what is the how containers and Dockers work hand in hand, so let's just talk about containers in an enterprise edition. I'll just give you an overview about how the enterprise edition of container works like. So there are basically multiple IT initiatives wherein container aligns to, and container helps in terms of different IT initiatives that a corporate environment has. And so I guess as we discussed earlier, it was the cloud initiative wherein the applications are currently moving from the normal on-premise servers, physical servers, to the cloud. So container and Docker can help in and support in terms of the cloud strategy. And there are different ways of modernizing the app in terms of moving from monolithic architecture to the microservice architecture. So containers and Dockers will help in terms of getting in that initiative done in terms of app modernization, and also for the DevOps guys, wherein they find a different way, more of a simpler way in terms of managing the application, and it is less resource intensive in terms of managing and deploying the apps when it is going via the Docker and the container pipeline way. So Docker is in the enterprise world, which is very definite, and that's what you see in different sectors on what containers and Docker support into. These are the few list of different sectors and domains wherein containers and Dockers pitch in. There are many applications which have started already using Dockers and containers since its evolution from 2016 to 2014, and it's been around 5 to 6 years, from which Docker and containers has been a boom. And it has been also evolving in terms of optimizing the speed and giving the uptime and making sure it's 24/7 up always. So at the end of the Docker, when we just try to make a gist of what we learned till now, these are the 3 points. The traditional applications in containers gain portability, efficiency, and security, and transforming it into the microservices. Looked for shared services to transform in terms of how we can make those tightly coupled services and just loosen it up so that there can be different services each doing their own specific job, and it can accelerate to a new application development innovation in terms of how we develop the applications and how we take care of the end users, and how the DevOps process is also included. So as a developer, we should also, or as a developer, or maybe someone who knows the application, we should be always keen to know about the end-to-end process on how we start the coding from the base, and what takes in between the process, and how it finally reaches to the end customer. So that's very important. So since we talked about the Docker and the images and how it works with containers and how those both work hand in hand, so I just thought of giving you a demo of how to play around with the Docker commands. And so this is Play with Docker. It's an online website wherein you can just create a classroom of Docker, wherein it provides you a command shell, and you can try around different commands that are available in Docker. You can also download this in your local machine. There's a Docker software available wherein you can run it on your local machine also. So this is just for the presentation purpose, wherein you can just try around with different commands and how to pull and display your images, and that's what I'll be just giving you a short demo on. So since we are aware of Dockers and containers and how it works hand in hand, I just thought of giving you a demo of how different Docker commands work and how it will actually look, and how I can pull and display the images in Docker. So this will be basically an SSH command shell that will enable us to play with different commands. You can also download Docker in your machine and play around with it. So I just hit on start. It will give me a 4-minute session wherein I can just add a new instance. There you go. And I'll just start with the Docker version. So this is the latest Docker version. And maybe I just pull on an existing public Docker image, which is hello world. There you go. And I just check the images. So it's Docker images. There you go. So this is a Docker image that I've pulled in, and this exists in Docker. So this is of each images pulled in Docker. There are different images that we can create. It can be public images, it can be private images, depending on what is the privacy or security required for that image and how it works. If it's your internal organization, it needs to be private, and you can just open it to everyone to contribute if it's required to be public. So that's how the Docker commands work. There are a few different commands which you can see around. So this is play with Docker classroom, where you can understand a bit of how Docker works, and from the basics to the from the basics to the advanced commands that is required in Docker. So there are a few individual labs and commands. You can surely try this out. This is one of the Docker images that I've created. It's around a year ago. This was just a demo that was created. So I'll just try on how to pull in my image in here. So I'll just copy this command and I'll just paste it here, which will enable to pull my there you go. So it's downloading the images, and it's a bit a big image because it's a .NET Core application image which I've created, and that's why it's a bit heavy. So it differs on, so there you go, it's around 271 MB, and the earlier one was around 13 KB. So it depends on how your images are and what are all the requirements. So that's how your Docker image is created, and that's how it runs on the containers. Yeah, so this was just a basic on how we can create images and how we can pull it. So this was just a few of public images that I created, and one which I created a year ago. So this is how we can play around with different commands in Docker. So yeah, so I guess how Docker really works, right? So we'll just look around with a video on how the different architecture on Docker is, and how it really works in the backend, and how it takes the images and how it processes it. I will just look on a real world scenario, and just to have a high level understanding, and just to wrap it up on what we learned till now.
How does Docker work? I mean, how does it really work under the hood? Docker is all about running single programs inside of a separated environment. In order to understand how this works, let's take a look at how the operating system is running a program in general. When you start a program, say your text editor, this program has a bunch of machine-readable instructions. The central processing unit is executing these instructions in ring 3, or user mode. In this mode, the CPU prevents your text editor from accessing anything it shouldn't. This protection means that when your text editor wants to open a file, it must ask the operating system's kernel for help. This call is commonly known as a system call, or syscall for short. The operating system's kernel, on the other hand, runs in ring 0, or kernel mode, which allows it access to everything on the machine. To open a file, your text editor gives the operating system a path of the file it wants to open. The operating system then looks it up and opens the file. Normally, two programs running on the same machine will see the same file under the same path. However, in Linux this is not always true. Using a few simple mechanisms, one program can see a completely different file system than another program. The same is true for many other aspects of running a container. Your program can have a separate virtual network card, its own set of processes, and even see the machine under a different name. In essence, your Docker container is nothing more than your application packaged up with some additional JSON files with execution instructions. When requested, Docker prepares your container and then hands it off to a container runtime like runc, which is responsible for talking to the Linux kernel to achieve separation. Since the container format is now standardized, you could even write your own runtime.
Yep, perfect. So that was just an overview of how Docker actually works, and how, when you just push the images and how it works internally as a system. So this was basically how Docker and containers work hand in hand. There was a small demo that I presented, and this was just on architectural level for the DevOps guys, and basically who is interested to see what is happening on the background. So this is how really Docker works, and this is just a Docker file, which we basically call as the config file, which I've created for one of my .NET Core applications and one of my Node.js web application. So what are the different tags that is there on the Docker file, right? So this basically defines on from where I just need to copy my SDKs. So this is again available on the Microsoft .NET core SDKs, wherein I can just pull in those SDKs which is required to compile and build my program, and I will just copy it on my temp location that will be my current working directory. And these are the Docker commands that I've mentioned in my demo, and this will be running as a command when I just execute this Docker file. So also the Docker commands which I ran on the sys command shell, that will also be automatically running when I just put this Docker file along with my application to the CI/CD pipeline. So that's how the Docker file actually runs in. So it will expose a port 8080, that is from where I can access this web application, and it will copy the project output, and it will just create a project name, and that will be the project name, and there will be a DLL created for an each .NET application. So this is generally how a .NET Core Docker file looks like. It's a multi-stage Docker file structure, and again it can be different for different kinds of applications. I've just demonstrated for .NET Core and Node.js web applications. So this is generally how the Docker file looks like. It will be just a YAML file associated with your project directory and the project file that you have, and you just need to deploy it using the CI/CD pipeline, and the rest will be taken care. It will execute those commands which are there on your Docker file. Since it is Docker specific commands, it will also run those Docker restore and Docker publish commands, which will actually build and execute and deploy your applications. So this is how generally a Docker file looks like. So building a secure supply chain application. So this is generally a Docker enterprise kind of architecture that we look in here. So this is what the Docker engine provides. It provides security, network volume, distributed state, and the container runtime. So this is what we call as orchestration. So there is something called as Docker Swarm, which we won't be covering in this session, but you can just explore on it. So Docker Swarm is basically helping out with the orchestration. There is Kubernetes, which also does the same part of it. So what Docker provides to us, it provides security, it provides trusted delivery in terms of support, and it also provides supportability. And what is the extra thing that provides in the Docker Enterprise version? So those are the few 6 points which are specific to a corporate environment. It can be policy management, it can be application and cluster management, it can be secure user access in terms of internal access or external public facing applications that we might have. It can be the content and the trust verification, wherein if it's in company specific data, how it will be protected and those kind of things. And it can be in private image registry that I mentioned earlier, wherein we will only have a private image registry for a specific corporate specific applications, and it can be a public registry for and developer who just need to play around with Docker. He can create public images and just open it for the rest of the public to contribute and play around with it. So that was basically what Docker and containers were. Just a brief to cover it up on a just basis. So Docker is basically a configure file, if you just talk about in a layman language, and which works on top of the containers, and Docker file is the core config file that is required for the container engine to run on your application. So both works hand in hand. And then we have orchestration tool, which I mentioned at the last, which is known as Docker Swarm or Kubernetes. You guys can search around with it, do a bit of research on those. So orchestration is again a big topic to cover it on how actually your config file works, and how it is translated to the Docker container engine, and how the control panel manages it, and how it actually runs at the end of the day as an application. So that's what orchestration takes care of. So these are the few references which I used in course of this presentation. Container as a service. So this is the documentation from the Docker Hub. This is again Docker documentation. They are very specific, very clean in terms of how are the steps that we need to follow in terms of creating or developing from the basics and the advanced level of Dockers and containers. So this is just a few of the Docker compute engines in terms of Google and in terms of Red Hat OpenShift. So these are basically containers that are provided from Google and Red Hat, which we can use it. There is a Docker file reference in terms of how we need to create a Docker file for different kinds of application. It can be .NET Core, it can be your Python, it can be your console, it can be your Node.js web applications, it can be any kind of applications, but there is a specific structure that is required to be there in that config file that is defined in the Docker file reference documents. So this was Docker in brief, wherein you saw the video on how it actually works on the backend level when the actual resources are divided and how the architecture on the backend server works like. So that's all I had in terms of Dockers and containers and on how it works and what is the overview of interrelation between Dockers and containers. I hope I did my best in taking you from the journey of a physical server and in terms of virtualization and how we are currently in the cloud world. So hope that gave you an overview on from where to start and from where to dig in. That's all I had for today. And on a key note, just to end, the best way to predict the future is to create it. This is something that I always believe in. Be a keen learner always in your day-to-day activities. Ask questions wherever possible. It will keep you on the toes and more evolving in terms of innovation. I would take this opportunity to thank my professors for giving me this opportunity to present in front of you on the trending technologies, and I hope I did my best. Thanks a lot, guys. Have a good day.
It was such a wonderful session on containers and Dockers, Mr. Prabhanath Nair. I'm sure many students might have learned something new and may have some queries. So now we will go ahead for our Q&A session. So let's see what our viewers have the queries on the topic. So our first question is, what is the function of the hypervisor between VM's architecture? The question is asked by Pawan.
Yeah, okay. So as I mentioned, right, so hypervisor plays a role in terms of the traditional architecture that we had in. So it's basically responsible to cater the different virtual OS that we have. So in terms of scaling up, the term basically defines as guest OS. So it will have a single OS and it is responsible for getting the different operating systems working, which we usually call as the virtual or the guest OS. So so that's pretty much the work of a hypervisor. It can be an firmware, it can be an hardware or even a software. So it depends on the architecture that we have in. So hope that helps.
Thank you for such an answer. Now we will go ahead with our next question.
Yep.
So our next question is, what is better, monolithic architecture or microservice, where every module is kind of individually built around? What is better and how? This question is asked by Rohan.
Yeah, okay. So Rohan, as I mentioned, right, so monolithic architecture is basically the traditional architecture which we used to follow when we had, business use case. And we had a business logic sitting somewhere and we had the database, logic sitting somewhere. But we can, further break down the business logic into bits and pieces. And that's what we call as microservices, wherein each and every service is only responsible to do a specific job. So which basically makes the application light. And that's pretty much recommended in going forward, and rather than having everything in a single place, which we call as monolithic. So it's preferred to have a microservices architecture in terms of scalability and a lightweight application. So that's what is preferred.
Thank you for such an informative answer. So let's see what our third question is.
Yep.
Third question is by Pranav Nair. You taught us Docker with respect to its general form with ASP and Node.js. But in terms of Python, it has more features as compared to ASP and Node.js. What do you say?
Yeah, so Docker is basically responsible to give you a pipeline and a streamline to make your things and lives. So all these steps that we talked about. You create a Docker file, it will create a image for you, and the rest is taken care by the container and where it runs it. So it's kind of same. The step is are basically same for any kind of software technologies that we talk about.
Okay, so let's go for our next question. It is by Nupur, and the question is, How can we get in General Mills in an upcoming college placement? What will be their expectation? Any specific technology requirement?
Okay. Uh, yeah, so I guess that's pretty specific to my firm. So I have been a part of the placement committee once. I guess I was recruited after, I guess, 2018 or 19. That was the year wherein I came to visit for that. So basically, there is no specific skill set that we require. And so, General Business not on the web technologies in terms of the containers and Dockers, and more looking towards the cloud architecture. So it's more on how much you have eager to learn, and that's what we are looking into. So there is nothing specific that I would say the interviewer or will be looking for, but it is more of how much you have and the eager to learn. So that's what we are looking for.
Okay, this was quite helpful because now the placements are coming for the last year students.
Yeah.
So now we'll go ahead for our next question, which is,
Yep.
can we have multiple Dockers running at the same time on a single machine? Can you shed some light on scalability part? This question was asked by Jay.
Okay. Yeah. So multiple Dockers is possible. So as I talked about the architecture that we had earlier, so let's stay with the environment. So both basically work similar. The only difference is, earlier we had the hypervisor and here we don't have an hypervisor. We basically has different of technologies like Docker. We can have Rocket files. Those are different technologies wherein we can create images, and it's more easier to scale in because there are a few shared resources in which we talk about an operating system. So there are less number of shared resources. For example, I have multiple Dockers running on a same system, and if some Docker is not at all used and it is down, but it is still active, but it is down. So the Docker hub and the container automatically takes those resources out, and it gives to the free pool, and the rest of the resources in terms of the traditional virtual machines. We also required each and every OS for each and every image. So that kind of helps in terms of
Hello. I guess there is some technicality issue.
Yeah, I guess I'm back. Yeah, sorry.
Okay. Yep.
Yeah,
So you can continue.
can you hear me now?
Yes.
Yeah, okay. So that was pretty much it. So the scalability is kind of easy when we talk about Dockers, because we don't have the OS and other requirements that an OS itself requires. For example, if I'm deploying a Python project and it only has a few libraries, which is around 15 MB, that I would say. But I also require the additional OS requirements, which is pretty much 3 to 4 times more in terms of I compare the project size. So that's kind of eliminated in terms of Docker, and it is easier to scale in terms of any kind of projects that we want to.
Okay. Thank you for the
Yep.
answer. Our next question is, can you suggest how should a beginner should begin learning Docker, like some courses or website? This question was asked by Raghav.
Okay. Yeah, so I guess it's Docker Hub is the best place for you to play around, and as I mentioned, Play with Docker is one of the online site which gives you the different flexibility in terms of playing around with Docker. You can also install it in your system, but if you don't have want to and you just want to play around. So Play with Docker is a website wherein you can go and check stuffs, and the Docker documentation, that's the best source that I would suggest. They have a pretty vast and descriptive documentation about each and every step that we need to proceed in further. So that should be the first step to go ahead.
Okay.
Yep.
So now we'll go for our next question, which is asked by Siddharth. So the question is, can Docker used as small size OS virtualization, like creating virtual nodes on network?
Yeah, so it kind of depends on your requirement. So for that question, I would say yes, but it also depends on how big your architecture or your system requirement is. For example, if it's just a small application, I would not invest more time in doing a Docker and stuff. It is basically depending on how large your application architecture is and how much the Docker can cater. So the definitely Docker is scalable, but it is more on your specific requirement. So the answer to the specific question is yes, but it also depends on your requirements.
Okay. So I guess that was our last question. Thank you, Mr. Nair, for answering all the questions. So now we have moved towards the ending of today's session. I would like to thank everyone for attending today's session, and special thanks to Mr. Nair for his precious time. I hope everyone had a great learning experience as he also clarified many of your queries. If you have any more queries, you can even contact him on the mail ID which is given in the description below. Please fill the feedback form for the certificates. The link is as provided as well in the description. Now I'll be signing off. Have a great day ahead. Thank you.
Yep. Thank you. Yeah, so I guess we are done with the live session, right?
Yes, yes.
Yeah, I was just confirming. Yep. So good job, guys, on getting this up. On live. So yeah, so there was some technical issues in between, but yeah, good job on getting this up. So all the best for your team.
Yes, yes. Thank you.
And
Thank
yeah,
you.
great job. Yep. So do let me know if you guys have any questions or yeah. Thank you.
Sure,
Okay.
sure.
Yeah. So thank you.
Thank
Bye.
you.
Thank you.